So I got myself set up here in the workshop now. What I've done is I've taken my laptop just as always, so the tool I use is Insider in SSIDER. Connect that to my Alpha NHA with its own dipole, put all the other antennas away, and then on the outside, now this is where it's actually for me quite important, behind that wall there, on the other side, behind all these metal shells and everything that I have in there is the RHA, same as last time. So I just wanted to show it under this kind of quasi bad lighting situation, so you could see this whole clearance, and then behind that concrete wall through all these shells, and so that's where the other device is that I'm connecting to with my Wi-Fi connection. Just going to turn on the lights now, and then I'll just run the experiment to show you what we are actually seeing here, and how the antennas, and specifically the new antenna that I'm using, is different. So just hold on a second. Anyway, so what I have is, as I said, my Alpha is here. What I want to show is the actual signal strength on the screen. So for the normal dipole as it is, so on the outside is a dipole, just stock standard on the NHA, R36A, sorry, this is NHA. Outside is a dipole, and this is a dipole. So link to link, what I read here is see now with lights I can't see it, minus 54. So I see minus 54 dBm, that's what I am reading as I have this antenna. Now, I can keep this thing here. You'll see a bit of movement. Obviously, it's not a perfect test. Again, this is a realistic environment. If I were to turn it like this, I may see a difference. There you go. So, the dipole on the outside is upright, and this thing is now horizontal. I see a signal of it's now minus 62. So definitely much lower than it was before, where I mentioned minus 54. So going back to this, it should go back. Again, it's not perfectly ideal, but it goes up. So it's now at minus 55. Yeah, up to minus 55. Now, what I want to do is change the antenna to the Alpha flat panel. Take this one off. This one on. As I mentioned, it's radiating towards the letters. On this one I did the test, that's what it is. Minus 52. So this is what I expect to see. Minus 52, so it's a little bit higher than the dipole. Good. And it's just looking better than the dipole. About 2 to 3 dB better, which this is a 7 dB and quoted, but there's a lot of reflections here, and a lot of things that you might see. Now obviously what you expect to see is if I turn this around, so now it is good away from the access point, I would see a drop. Do I see a drop? I see a significant drop. It goes down to minus 63 again. So yes, that's definitely weaker. So you can see the antenna is directional this way, it's not good that way. Turn it back. Now the other test that I just wanted to show you as I am live, this is waited for it to go back to the original value of minus 52. It's jumping, it's going up. There you go. It's getting there. There we go. I'm happy now. So it's at the high level of minus 53. High is relative. Now if I turn this like this, it's vertical to a horizontal antenna. So you basically have two antennas not supposed to communicate to each other because they're in different orientations. You see a drop, and you can see a drop on my test going to minus 65 dBm. So it's down significantly. Still facing that way, but it's not working. It's climbing up again, because obviously the antenna has another idea what I should see. It's still low. It's minus 61, and it's the high gain and component going forward. So the high gain facing forward, but it's cross towards the other antenna on the other side, and it's just not that good. If I go back like this, it should be back to a strong signal again. Why this is useful is in tunnels and in multi-reflection areas, like we call it urban canyons, or those kind of applications where there's a lot of reflections. Your signal is dirty. So you may transmit clean, and you may think you receive clean, but in between your radio wave gets reflected so many times that you actually don't know what you get on the other side. And that's in tunnels, And also the guys that fly drones, the first person viewer, FPV, they all want circular polarized antennas. Not because circular is better, but because circular gives them the assurance that there will be a signal coming to them and they can pick it up. Now with a 3 dB, with a circular polarized antenna, you're guaranteed 3 dB loss. So if it's perfect to perfect, a circular is less ideal because you actually incur 3 dB loss because the antenna is actually able to pick up everything, but it's not going to pick up your correct one perfectly. But it always picks something up, and that's what I want to show you on the other one. So you see it's consistently now at minus 54, 53, so the antenna is behaving as it should. Now let's go for the big test that I really wanted to show, because this is, I'd say, RF Shopper Blackheart Technologies' claim to fame. So here's my baby. So now it jumps up. Because of that 3 dB loss, it's quoted as a 7 dB antenna, which is correct if you had circular to circular, but you can expect it to be close to the dipole. But the thing is, oh, there you go. So it's now facing out, and it's upright, so the feet would be normal. And I'm just having it here because this is what I did with the other antenna, so it is a like for like comparison. And I am seeing minus 54, minus 53. Actually, it's performing just like the alpha antenna, but it's circular polarized. With being circular polarized, it means that it's picking up anything right now. If I were to turn this antenna around, see, I'm actually moving, so I'm messing it up. If I turn this by its side, practically no difference, minus 55. So what this antenna is doing, it is picking up everything that it gets. I don't care about the orientation. Now in a multipath, this is only one wall and one set of shells in between. So, but if you have a big house between your living room and the study totally on the other side, this kind of antenna would be able to pick up all the reflections that comes through. And the gain is 7 dB, so the gain is comparable to the other antenna as well. Right now it is sitting at minus 50, so actually it is behaving better than the alpha 7 dB antenna. Yeah, well, what can I say? I'm happy. Now, just to be fair, if I point this away, so now I'm pointing this way with my antenna and nothing is going that way, I should see a significant drop, because that's the idea, because you can't just make power out of a antenna like this. You actually you take away power from the back, from the rear, and pushing it forward. It probably is picking up reflections as well from there. No, it's going down. It's going down. Yep, minus 65. So this is low. So obviously this is low, and that's expected because it's now tracing with the back towards where I want to go. Not doing very well, but that's what I want. That's the design intent, is that it actually works from this side. So if I go back again, I point it that way. And just wait for the whole thing to stabilize. So my new antenna is facing out, and goodness gracious me, minus 50. And I saw cap, because if I put my attenuators out, it actually never goes above minus 50. So it's working. I used the word I'm kicking butt. I apologize for saying that. It's kind of a bit blunt to say that on a previous video, but I'm kicking goals, and I'm happy with this. And the next step for this antenna would be to take this, just make the colors a bit better, have a few minor things to tweak, but I'll talk about weeks here. Weeks, maybe months, then this thing would be a product. I'm going to have a special offer, and then, as I said, the next thing would be going to have the same antenna in a 1-port configuration like this one, then a 2-port configuration. So in the same form factor, so in this kind of little enclosure like I have there's another one. Just going to have 2 ports, and from the front you'll have 2 antennas, 2 radiating elements. It is there. I actually have done it already. It's just I start slow. Then the next step would be to use the same idea, just make a little bit wider, so that we have 4 antenna ports. So 4 antenna ports, so your typical access point at home or so that has 4 antenna ports can connect into one body and faces into a house. This is the first iteration. It's desktop mount, so it's an indoor antenna, but I'd say it's desktop mount, so the idea is you just have to put it on a surface of some sort. The beauty, I guess, of the circular polarized is if it's a little bit skewed this way or that way, it doesn't matter. Also, it's not overly directional, so if it stands a bit to the back, or if it has to be a little bit forward, that's okay, because there would still be a lot, probably almost the same going forward. And then the next one would be the 4-way, and then the next step would be outdoors. This is black. There would be a white version as well. This shows that it works. It's yeah, it's going well. I'm mucking around it, so that's it. I'm actually pretty happy to be able to show you my Wi-Fi antenna, and this is the one on our next outdoor test. We're going to use R36A. There was a question on Facebook, what am I going to do in my outdoor test to improve my situation, because I had a link but I didn't really have data throughput. This is what I'm going to do on the R36. So the first step would be I'm going to improve my setup at my router, and then after I have a link that looks different from the one I had in the past, then I'll start to look at what else can I do further. But this is the answer to the question that I had. What am I going to do to fix my problem that I saw there? So that's it for now. Thanks for watching. Sorry, it's kind of a bit of a long one. I appreciate watching, and like this channel, please do, and like this video, and tell your friends what I'm trying to achieve here. Thank you. Bye-bye. Quite well, because there's a lot of reflections here. There's something happening that's doesn't really work. Let's have it here. It rises a bit, so it goes up. So now I can see it goes up to -50. -58, -60. So not what I wanted. That goes up. See, this thing gives me the shits. -52.